So with that, Mr. Takei, you have
Yeah.
the floor.
Okay, yeah, thank you so much for your introduction. So I like to start my presentation. So can you see my screen at this moment?
Yes, we can see it.
Okay. Wait a moment. Okay, so let me start my presentation. First of all, so my name is TAKEI. I am a managing director of NSOG Energy Solutions Thailand, NSET. Today, I want to make a presentation for the JCM project in 2019. In this project, we installed a heat exchanger in the cogeneration system in order to improve efficiency of cogeneration. First of all, so I want to introduce our company, NSOG Energy Solutions Thailand, NSET. NS stands for Nippon Steel, and OG stands for Osaka Gas. We are a joint invested company of Nippon Steel Engineering and Osaka Gas Singapore. So we are established 9 years ago, and now so we are operating gas turbine or gas engine cogeneration boilers and chillers for the customers such as Honda, Toray, Yokohama Rubber, Honda Gang, and Spiber. And so now we operating this facility in order to supply heat and power to these factories. And this JCM project is done in the premises of Toray Textile Thailand. Toray Mill 2 factory is located in Samut Prakan in Thailand. In the Toray factory, we are operating 7 megawatt gas turbine cogeneration in order to supply electric power and steam to their factory. In this JCM project, we additionally install heat exchanger in our existing gas turbine cogeneration. This project is done with Nippon Steel Engineering, who is a technology provider. In Thai Torres factory, we are operating a 7 megawatt gas turbine cogeneration. We've designed, constructed, owned, operated, maintained cogeneration facility in the premises of Thai Torres. We've done everything about cogeneration, including EPC, funding, fuel procurement. We supplied energy to Thai Torres factories and also sells surplus electric power to MOEJ under the VSPP scheme. This is our photo of 7 megawatt gas turbine cogeneration for TTT. We constructed this facility in the area of 900 square meters. The capacity of power production is 6,700 kilowatt. Steam production capacity is 41 ton per hour, and its original overall plant efficiency is 91%, which is among the highest efficiency in cogeneration. Since the cogeneration is highly efficient, so we've achieved high PS of 25%. Primary energy saving PS is an indicator used in Thailand to evaluate the efficiency of cogeneration. This PS implies this plant reduced primary energy by 25% compared to the boiler, of which efficiency of is 85%, and the gas turbine combined cycle, of which efficiency is 45%. And this plant can contribute more to primary energy saving rather than highly efficient boiler or so advanced gas turbine combined cycle plant. In fact, we've reduced carbon emission by 13,000 tons per year after installing cogeneration. Also, we've proved that we contributed to stable production of the factory by continuous power supply at the occasion of power grid trouble. So therefore, we reduced CO2, we contributed to the stable production of the factory. So that's why, this plant were awarded Cogen Award, 2018 in Japan. Okay, and in this slide, I'm showing schematic process flow. Basically, this cogeneration plant consists mainly of a gas turbine and heat recovery steam generator equipped with a duct burner. In order to achieve high efficiency of the plant, heat recovery steam generator is key because cogeneration is a technology to make the maximum use of waste heat. And to be honest, we cannot control gas turbine efficiency, but we can control efficiency of HRSG. So that's why we designed heat recovery steam generator in order to fulfill a high steam demand of 41 tons per hour and achieve a high boiler efficiency. In this JCM project, we modified this heat recovery steam generator. To be specific, we installed additional heat exchanger in between economizer and stack. Next slide shows a schematic illustration of the project. As I said, we installed heat exchanger. We planned to make the maximum use of gas turbine waste heat in the exhaust gas of gas turbine in order to heat up boiler feed water. So that's why after heat hex installation, basically we can confirm the reduction of temperature of exhaust gas, and we increased feed water temp. And then next slide shows a summary of the result. X-axis represents gas consumption in duct burner. Y-axis represents steam amount, steam production amount. And this light blue rectangle shows hourly data before hex installation. And this dark blue circle shows the data after hex installation. In this graph, you can see the regression line has become steeper after hex installation. Technically speaking, the slope of regression line corresponds to boiler efficiency. Therefore, so in this graph, you can see boiler efficiency was increased by more than 10% after hex installation. And this is the final slide. And as I said, we improved the boiler efficiency. That's why we also proved that overall plant efficiency has increased, and also PES value was improved. And as a result, this plant has become probably most efficient cogeneration plant in Thailand. In conclusion, in this project, we additionally installed a heat exchanger in the existing cogeneration. And as a result, so we improved boiler efficiency by more than 10%. And this plant has become probably most efficient cogeneration plant in Thailand. So I believe cogeneration is still a practical energy saving solution for large customers. So that's why large team users, and thus we hope the cogeneration will be promoted in Thailand. Yeah, thank you for your attention.